This is Josh. Let's get started with triangles. I wrote a bunch of stuff on the board here because for me, when it comes to this lesson, I like to have everything kind of laid out. And then once I've done that, then I can use this information to solve all the problems. All right, so let's just jump right into these, shall we? We shall. According to the book, and again, I'm just using their labels and stuff like that. I like to use those, but at the same time, I want to put these in like student-friendly terms, so we're not just like, well, these are so technical, nobody understands them. Like, let's just make this more practical. Acute triangles. And again, all of this has to do with triangles, okay? An acute triangle is when you have, now hopefully you remember, I guess I could take a step back. Acute angles, remember, are smaller or less than 90 degrees. Obtuse are greater than 90 degrees. Right angles are 90 degrees, okay? And then we have these three different types of triangles based on that. So let's just classify everything and then we'll keep going. So acute, you can, and again, I'm very visual, so I'm going to draw one. Like we could have one where it's like that, okay? Where, let's see here, the book says just all acute angles, okay? All acute angles. So this could be like, 40, 30, 60, whatever, they're all less than 90 degrees, okay? So you could even say all less than 90 degrees, okay? When it comes to these, like I said, do what's going to work for you, okay? And again, I always tell my students on a test, if you were able to like get your test and then write this stuff down on it, do it, right? Because now you have a template that'll help you solve every single problem. So we have our acute triangles. Let's move on to obtuse. And an obtuse triangle is going to be one where it's more like, let's see here, maybe I can draw like that, where one of the angles is obtuse, okay? So we could say one obtuse angle, okay? And the other guys will probably have to be acutes. But if you have one angle that's obtuse, it's an obtuse triangle, okay? And the book just says one obtuse angle, all right? And then we have our right triangles, and those you're probably the most familiar with. It has that little corner symbol, right? The little box which tells you that this is a 90-degree angle. And so we can say one right angle. Okay, hope you can read my writing. I got all acute angles. All are less than 90 degrees. You could write that. This was a comma. There you go. And then we have an obtuse triangle where we have one angle that is larger than 90 degrees. So one of the angles is obtuse. And then we have a right triangle here where one angle is a right angle. Okay? All right. So now let's get into scalene, isosceles, and equilateral. I will use the terminology from the book, but I'll also talk through it. So a scalene triangle has no congruent sides. Okay? Congruent means equal, essentially. So what we could say here is that we have no equal sides. I'll just say no equal sides. Or you could even say like no sides the same length. Whatever's going to help you remind yourself. Scalene means that none of the sides are the same length. Okay? No equal sides. No congruent sides. However you want to say it. Isosceles, it says at least two sides are congruent. At least two sides are congruent. Okay, so at least two sides are the same length. Okay, so we could say two sides are equal, or two sides are the same length, if that helps. Okay. And then we have equilateral, which means that all three sides are the same length. And the book just says all sides congruent. All sides congruent. Okay. And so now they're going to give you a bunch of triangles. But again, this is why I like to have this listed, because then I just look at the problem. I know what I need to do, and then I just kind of go from there. And so when it comes to solving these, you're going to need one answer from the top, one answer from the bottom, and that kind of brings your answer together. Okay? And as you start to see that, you'll figure out like how the puzzle pieces fit together. So let's see here. Classify this guy. What is that? 50 and 40. So they kind of drew a triangle. I'm going to draw it right here like that. Okay, we got a 50-degree angle here. Oh, that's bad. 50 degrees, 40 degrees. And then my last angle here, they were nice and they gave me that little symbol. Okay? So now I need one answer from the top, one answer from the bottom. Well, what kind of triangle? Is it an acute, obtuse, or right? I noticed that symbol, which means it's a right triangle, so I'm good to go. So this is a right. Okay, let me just make sure I got all my little things here. And then I got to look at my angles, okay? Or I should say my lengths. Sorry about that. And so I got to look at my lengths. Do I have 3 different sides that are all different lengths? Do I have 2 that are the same? Or do I have all 3 that are all the same length? Now, hopefully in the book, the pictures are pretty obvious. And if you aren't sure, because you have a book, I would say use a ruler, use a piece of paper, use a pencil or marker, right? Just put it there and measure all 3 of the sides. And, just use your fingernail and kind of like to say, okay, those are about the same, or they're not. The goal of the book is not to trick you by saying, well, that one's technically 11.1, and this guy here, this is 11.1, this one is 11.2. Right? They're not going to do that. And if they are, then that's a bad problem. Okay? The goal is to have you differentiate and understand what's going on here. Understand that you need to pick a type of triangle. Is it acute, obtuse, or right? Label it. Then, is it scalene, isosceles, or equilateral? So based on looking at these sides here, let me erase some of that. This side here, the hypotenuse, is the longest side, and it is longer than these 2 guys. And so this guy is a right scalene. Okay, do your best with the spelling. I personally don't take off points for spelling on math problems, but, make sure I understand what you're saying. Okay, so this guy here is a right scalene, right? We do top row, bottom row, right scalene. Sometimes you'll have acute scalene, acute equilateral, obtuse scalene. You can get all these combinations, and that's what you're going to be solving for. So let me do one more of these guys right here. Let's see here. This one says, okay, let me draw this guy. And I guess I don't really need those measurements. So I'll just do 68 degrees. Let's see here. This guy here is 44. Okay, again, they're going to give you the measurements, and then they're going to give you what else you're going to need. And by that, I mean they might give you some extra symbols. Okay, so in this one, if I know that this angle and this angle are the same length, or the same measurement, then I know that this guy is going to open up equally on both of these sides. Now, if you're still not sure what that means, they're going to give you an extra hint. And by that, they're going to draw these lines through those sections of the triangle. Really, what they're trying to say is that this side is congruent to that side, or this length is the same as this length. Okay? So let's look at our triangle, figure it out. Is this guy an obtuse? No, because there's nothing bigger than 90. It's not a right, so it's an acute. So I'm going to write out acute. And then let's take a look. Is it scalene? Well, they drew these lines in here, which tells me that 2 sides of this thing are the same length. So it's not scalene. It might be isosceles, but this one says all sides are the same length. Do we have all 3 lengths the same? No. And could I take a ruler or a pencil or something and measure and see like, these guys are the same length, and then this guy's a little bit bigger. And if you notice that, then that's awesome. So this guy would be considered acute because that's our top row answer. Bottom row answer, isosceles, because it has at least 2 sides that are congruent or 2 sides that are equal. So this is an acute isosceles, right? Sorry, man, I'm a math teacher. Spelling is not my game. But you know what? I got it written right there. So I just copy the word. Okay, so this is the first part of the lesson. This is what you need to do. And I think it personally is a lot easier if you have this written down. I know it's in the book, but write it in terms for you that make sense to you so that you're not like, what are these technical terms, right? It gets really confusing. Okay, so I'm going to leave that on the board. I don't really need it, but you know what? I'll just leave it right there, okay? The next thing that you're going to need to do is sometimes they'll give you a triangle where there's like 2 measurements and you don't know the third one, okay? Like this. Let me just draw a triangle here. They said this guy was X. They said this guy was 53 degrees, and this guy is 50 degrees, okay? They're going to say, figure out the value of that and tell me what type of triangle it is. Okay, well, we'll figure out the measurement first. So we know that all 3 of these interior angles equals 180. So I can write that out as a math problem if I want. I can say 53, oh my gosh, that's bad. 53 degrees plus 50 degrees plus X equals, X degrees, I guess, equals 180. And now I can combine like terms. I can add the 53 and the 50 and get 103 plus X equals 180. Sorry, I get lazy with them degree signs. And now I got to solve for X. So you could eyeball this, which takes forever, or you could do the algebra way, which I always recommend, and isolate the variable, which means we're going to subtract 103 from both sides, right? Because we're adding here, so we do the opposite and subtract. So X degrees equals, and again, use your calculator, right? Well, I mean, if you're allowed to. Let's see here. 180 minus 103 equals 77 degrees. Okay, so I know this guy here is 77, and now I need to label what kind of triangle this is. Okay, well, let's look at the angles, right? I got an answer from the top, and I need an answer from the bottom. Is it acute, obtuse, or right? Well, none of them are 90-degree angles. And none of them are obtuse. So therefore, all my angles are less than 90. So this guy is an acute. Okay. And then based on the measurements, and this is where it gets a little bit tricky, okay? You kind of got to look at the angles and say to yourself, well, if the angles are different sizes, then the length opposite of that angle is going to be different as well. Now, like in the previous problem, we had 2 angles down at the bottom that were the same length. So if they're opening up at the same length, it's pretty safe to assume that those sides are going to be the same length as well. This guy has a 53, a 77, and a 50. None of those are the same lengths, but they're all less than 90. So we know it's acute. And so we know that the sides are, let's see here, they're not all the same length. I don't even have 2 that are the same length. So this guy is an acute scalene, okay? Give me both answers. Don't just give me 77. Don't even make a degree sign next to it and forget this part. Make sure you give me 2 parts for every answer. What is the measurement? And then what type of triangle is it? Okay? The last one I want to do here is just one more addition here. And I know you're going, man, we are going fast. So as always, feel free to pause the video, go back and watch it again. I'm trying to keep these short and sweet and get you through all this math. Okay, so in this situation, we have kind of like a triangle connected to a line, all right? And the goal is to figure out the measurement of one of these angles. So in this situation, they said, figure out the measurement of X. And then they gave you some other things to work with. They said that this guy here was 118 degrees. And then they said that this guy in here was 28 degrees. Let me just make sure. That might be a 25. Oh yeah, it's a 25. Always check your work before you do it. I could have got really stuck. Okay. Now, there's some assumptions we have to make. We have to assume that this is a triangle, okay? I mean, it looks like it, and the book does a good job, but, right? And then we have to assume that this is a straight line, okay? And we need that rule that we used like a lesson or 2 ago when we worked with straight lines. The angle of a straight line, or the measurement of these degrees, is 180 degrees, right? A straight line is 180 degrees, okay? So if I know that this portion over here is 118, then I think I can figure out that guy, okay? And hopefully you're looking at these as just like, there's puzzle pieces, okay? And it's a matter of figuring out what can I label, what can I do so that I can get to the next part, okay? And they're giving you these for a reason. If I started with the inside of the triangle and just said, well, I got something plus x plus 25, like, psh, dude, I have no way of knowing what the value of x is. But if I start on the outside, I can say, oh, well, 118 plus something is going to equal 180, right? Because that whole length there is 180. So let me do that first. I have 118 plus, I don't know, I could just say x, I don't know what it is, or b, whatever. This plus this little guy here, equals 180. You know what? I'll change that to a, just because that way it's not that, okay? And so now what I need to do is solve for a, okay? Because I want this little measurement in here. So I subtract 118 from both sides, and I get a degrees is equal to 180 minus 118, which again, get your little handy dandy device here. 118 is 62 degrees. Okay, so now I know this guy is 62 degrees. So I have a 62 degree angle, a 25 degree angle, and then an I don't know angle. But that's the guy I'm being asked to solve for. So now what I can do is use that rule like we just did in the previous problem, where we work with the interior angles of the triangle. So if and again, if it helps you to redraw, because like I'm kind of doing a lot of crazy stuff here, if it helps you to redraw the problem, then I say do it. So I have my triangle here. Again, they don't have to be done to scale, but just do your best. I got x, I got 62 and 25, okay? If I know that all of this, well, I know it's a triangle, so therefore I know that x plus 62 plus 25, all of these interior angles have to equal 180 degrees, right? I had to do that dramatic pause so I could make sure you're following along, make sure you're like, oh yeah, dude, I know that, triangle, 180, got it, boom. Okay, now let's just solve for x. So let's combine like terms. 62 plus 25, oh my gosh, this is so much math. 62 plus 25 is 87. Okay. And now we're going to, again, numbers on one side, x's on the other. So I'm going to isolate the variable. I'm going to do the opposite of plus 87. I'm going to subtract 87. What I do to one side, I do to the other. I know I forgot all my degree signs. I'll do my best to write them down in the future. But when it comes to your answer, definitely write the degree sign in, okay? So I got, what is that, 180 minus 87, which is 93. Okay, so let's see here. Find the value of x. I didn't have to tell them what type of shape this was, so that's kind of nice. All I had to do was solve for x, and that's a 93. Sorry, it's kind of messy. Okay, so be careful with these, but remember your rules, okay? And that's why it's important you remember, oh yeah, straight line is 180. A triangle or interior angles of a triangle are 180. Use the rules so that you're able to work through this extra math, okay? All right, so good job on this. Take your time with these, okay? As you get better at this, maybe you don't need to label everything. But in the beginning, I say it's easier because it's a great little cheat sheet that you can kind of use as you do all these problems, okay? So great job today. Send me some more jokes. Sorry we couldn't get one in today. I was just a little bit too intense on the math and I didn't think about throwing one in. But I'll try to get one in on the next video. Thanks for watching and I'll be seeing you soon.